Hello, my name is Ritesh Bharat Kadam and my qualification is MSc Physics from Mumbai University. Okay, so today we are going to start with the chapter 12 atoms. So directly taking into the chapter, let me take you to some history part. In 1898, J.J. Thomson. In 1898, J.J. Thomson just give us a little bit of knowledge about atom. He compared the atom with the watermelon. He said that whatever the positive charge we have, that is like the red pulp which is inside the watermelon, and the negative charge inside an atom is like an seeds inside the watermelon. Okay, so that means जो भी लाल कलर का पार्ट होता है, रेड कलर का पार्ट जो भी हमारे पास है वाटरमेलन के अंदर, it is a positive charge. Similar way, the positive charge is embedded into the atom, and the electrons are there which are like a negative charge. Like if this is a watermelon, there are some seeds inside which we will term it as a like an electrons, and red part which will be like a positive part inside an atom. Okay, so this is explained by the J.J. Thomson, but later on this becomes and there are lots of drawbacks come from this theory, and one of the famous scientists, Rutherford, just gave us a bit of explanation or a detailed knowledge about the atom. He did one experiment. Okay, let's check it out what kind of experiment he have done. So now what Rutherford did, actually Rutherford also didn't got the exact answer, but his students, the two students, the name is Geiger and Marsden. Okay, these two students help him to obtain the analysis from his experiment. What he did, he took one radioactive element. The element name was bismuth. Okay, and he put this radioactive element inside a lead box. Now why lead? Why lead he is taking lead box? Because lead is a good radioactive absorber. So whatever the radiations are coming out of this element, he wanted that that radiation should travel in a particular direction so that he can obtain some analyze, or he can analyze some data. So that's why what he did, he took some brisk. Okay, and he kept over here. That brisk was made up of lead. Okay, now whatever the radiations was coming out, all these were traveling in this direction. Now he put one gold foil in the middle of this path. Okay, and that the thickness of that gold foil was nearby 10 power minus 6 to 10 power minus 8. This was a gold foil. Now why he choose the gold foil, again that is the question. Okay, he choose gold foil because the malleability property, that means we can make a sheet of a metal. That property is very good for the gold. We can make a very small, or we can make a very thin kind of sheet for the gold. It is nearby, we can say, a one layer of atom in a one sheet. That kind of that much small we can make. Okay, so that's why we are taking, or Rutherford took the gold foil. Now this radiation fall on this gold foil, and now he placed the zinc sulfate screen on the backside of this gold foil. Now what happens, he observed some light sparks over here, and he did some analysis. Okay, he took thousands of nuclei, and he analyzes something. He found so many observations that we are going to see. Some radiation were making angle theta, some were passing. So what kind of observation he have observed, that we'll see now. Now let's go to the analysis part. Hope you have understood what is experimental setup. He took one radioactive element, he put that radioactive element inside the lead box. Now the radiations were coming out, so he wanted that radiation to be go in a particular direction. That's why he took a brisk of lead box, which are good absorber of radiations. Now this travel in a straight line, and he put a gold foil in between that, so that the radiations will fall on the gold foil, and after passing from the gold foil, this radiations fall on the zinc sulfide screen, okay, where he find out where he observe the little bit of sparks, light sparks. Okay, so what he concluded, let's see what he concluded from this activity. First of all, what he observed that nearby, first observation, what he observed, okay, observations. What he observed that nearby approximately 99.86% of nuclei, what I am saying, 99.86% of nuclei just passed undeviated. For a normal person, if we'll see that nearby 99.86% nuclei are going undeviated, so what we'll say, we'll just leave the topic and we'll just wind up everything and we'll go home. But these are the scientists which are very great. So he observed a very small part, which is very important. Now second conclusion, nearby 0.14% of nuclei he found who were deviated by greater than 1 degree, whose deviation was greater than 1 degree. How much? 0.14% of nuclei. One more thing, 1 in 8,000 was deviated. What is the meaning of deviated? Okay, let us suppose if somebody is traveling in a straight line, if he changes his path, original path, then we can say that particle is deviated. Now 1 in 8,000 was deviated by more than 90 degree. Deviated by more than 90 degree. Okay, now what is the meaning of more than 90 degree? Why these are deviated? Now suppose, see, the radiations are coming which are nothing but what? Alpha particles. Which are what? Alpha particles. Alpha particles means what? Whose atomic number is He24. Now these are very heavy particles, plus the charge of this particle is positive. Okay, so now if somebody wants to repel this, then what kind of charge that particle should have? That particle or whatever that object should be, that should be also of a positive charge, then only it can repel this He. Okay, so what are the conclusions from that? We'll see in 2 minutes. Now one more observation he have observed, 1 in 10 power 6 nuclei. What I am saying, 1 in 10 power 6 means, that means nearby 10 lakh nuclei, one atom was coming or deviated through 180 degree. Oh my god, 180 degree. 1 in a 10 lakh was deviated by a 180 degree. Can you imagine? He was waited for this one nuclei. Who can see? Now He, alpha particle, is very heavy particle, whose we can say the charge is very big. Okay, so now what we can say, who's that? Or if somebody is having a lots of power, if we have to repel them, then we should also have a lots of power. So what he concluded from this, again, what are the observations? Let's see. 99.86% of nuclei passed like undeviated. So let us suppose we have a the net or something, big net, and if I'll tie one eye mask on your eyes, and if I give some stones to you, if I'll ask you to throw that stones, okay, now let us suppose you are closing your eyes and you are throwing a stone. Now what will happen if that stone pass without any sound? That means what you will say, there is an empty space. But if that stone strikes to something, what